Wow, it's trending now on every side and make everyone think how, why, what. Everyone is curious about it and no one is giving a clear description about it, so I decided to make a research-based video on it. So let's see what my research says. It tells us that Ryugu and Bennu are two different near-Earth asteroids, but new research has suggested that they were likely once part of the same larger asteroid, called a parent body. Oh, here it got interesting for us to think. They have same origin, but they are now so far from each other. How they scientists get about it, let's know. The two asteroids, which have the same darkness as charcoal and are shaped like spinning tops, have the distinction of having both been visited by spacecraft in recent years. Japan's Hayabusa 2 spacecraft visited and collected samples from Ryugu, and those samples are currently en route to Earth. NASA's OSIRIS-REx mission has been orbiting Bennu since December 2018 and will collect samples from the surface later this year to also return to Earth. We have the very exciting chance that two space missions visited two primitive near-Earth asteroids at about the same times, which allows us to discover two new small worlds, said Patrick Michel, study co-author and director of research at the French National Center for Scientific Research in Paris. Really good. I admire. What really fascinated us when we saw the first images is the amazing similarity of the two objects, before more detailed observations made differences emerge. This is really fascinating because these asteroids were chosen totally independently from one mission to the other. The dual space missions are shedding light on the nuances of these asteroids that would have been impossible to know from Earth. The close flybys of these spacecraft by the asteroids have revealed how similar they are. Both are carbonaceous type asteroids, meaning that their composition includes a large amount of carbon. Ryugu and Bennu are both rubble pile asteroids, meaning they are groupings of rocks held together by gravity rather than single objects. And both feature large impact craters on their equators. This led researchers to believe that these asteroids were remnants from larger asteroids and that they may have originated from the same asteroid family, said Ronald Balouse, study author and postdoctoral research associate at the University of Arizona's Lunar and Planetary Laboratory, in an email to CNN. Over tens of millions of years, near-Earth asteroids either collide with Earth or get sent toward the Sun when they interact with Earth's gravity, Balouse said. Okay, what's next? Population of near-Earth asteroids is replenished by the fragments that come from collisions of larger asteroids, about 62 miles in size each, in the main asteroid belt between Mars and Jupiter. These small pieces are ejected, but because they follow each other, their mutual attraction is high enough to make them reaccumulate and form a family of aggregate asteroids after a few hours, Michel said. This is how asteroid families form in the belt. Hey, if you think video is getting useful, then give us a like, subscribe our channel. The fragments from the larger asteroid, and whatever remains of the parent body, form what astronomers call an asteroid family. These fragments, which become asteroids, can be placed on unstable trajectories that change their orbit from a circular one to an elongated one that makes it cross the orbit of the Earth, Michel said. This image sequence shows how fragments reaccumulate after an impact to a large asteroid. The final shape, 5 hours after the beginning of the process, is similar to that of Bennu and Ryugu. Both Bennu and Ryugu's similar orbits could be traced back to the same region in the asteroid belt. But when the two spacecraft reached Ryugu and Bennu, researchers noticed some key differences. The biggest difference is that Ryugu was much drier than Bennu, which caused the astronomers to question if they were, in fact, twin asteroids from the same family. However, the latest research from the teams investigating both asteroids has revealed two different scenarios that could be responsible for the varied water content in the asteroids. The study published this week in the journal Nature Communications. Thanks for watching and feel free to comment us.